Assalamu alaikum and welcome to the medicinal chemistry lecture notes. Today we are going to discuss about the synthesis of acetyl salicylic acid, most commonly known as aspirin. The chemical structure of acetyl salicylic acid is shown here, the derivative of benzoic acid along with the acetyl group. Now let's discuss about the synthesis of acetyl salicylic acid. The first pathway for the synthesis of aspirin or acetyl salicylic acid is via acetyl chloride. The acetyl chloride is CH3, C double bond O, and Cl. This is the structure of acetyl chloride. Now let's discuss about the synthesis. The starting point for synthesis of acetyl salicylic acid is the salicylic acid along with the CH3C double bond OCl, that is acetyl chloride, in the presence of the pyridine and the glacial acetic acid. It will form benzene along with the carboxylic group and OC double bond of CH3. So this is the acetyl salicylic acid along with the libration of the CH3C double bond OH HCl. This is the first pathway for synthesis of acetyl salicylic acid. Now let's discuss about the second pathway, that is via acetic anhydride CH3C double bond O C double bond O CH3. So the starting compound for the synthesis is again the salicylic acid along with the addition of the acetic anhydride. It gives in the presence of the pyridine, it gives us acetyl salicylic acid C double bond OH O C double bond O CH3 and two molecules of CH3COOH. I hope it makes sense. Thank you very much. Allah Hafiz.
Assalamu alaikum. In this video, we are going to discuss about medicinal chemistry of acetaminophen, commonly known as paracetamol. This is its chemical structure. So these are basically para-aminophenol derivatives, and the paracetamol or acetaminophen is also known as para-hydroxyacetanilate. So as far as the synthesis is concerned, the starting compound for the synthesis of paracetamol is phenol, which undergoes nitration, nitric acid or H2SO4, will ultimately form as para-nitrophenol. This upon reduction gives us an intermediate compound. The resulting compound is para-aminophenol. So because of the reduction, then this para-aminophenol undergoes acetylation in the presence of acetic anhydride or acetyl chloride. It will form paracetamol. Thank you very much. I hope this makes sense. Please subscribe my channel. Allah Hafiz.
Assalamu alaikum and welcome to the medicinal chemistry lecture note. Today we are going to discuss about the synthesis of salicylamide, another compound in non-narcotic analgesic. The salicylamide contains a basic structure that is seen in acetyl salicylic acid. The common name is orthohydroxybenzamide. Instead of the carboxylic group, we have a amide group. Let's discuss about the synthesis of salicylamide. As usual, the starting compound for the synthesis of salicylamide is the salicylic acid. In most of the acetyl salicylic acid derivative, the starting compound is salicylic acid, so it's easy to remember for the synthesis of salicylamide. It undergoes acetylation and it yields salicyl chloride. Salicyl chloride, that is the carbonyl carbon along with the chlorine, and OH is the same position as in the salicylic acid. This, upon further reaction with NH3, now yields salicylamide. The carboxylic group along with the NH2 group, the chlorine is removed and leaving behind NaCl. The uses are of salicylamide as an analgesic, as an antipyretic. The main SAR for the salicylamide, as it is a derivative of acetyl salicylic acid or salicylic acid derivative, it is non-inflammatory due to the absence of the carboxylic group. The common ADRs, as usual, the gastric issues, also causing sedation at high doses. This is all about the medicinal chemistry and synthesis of salicylamide. I hope you people Understand it? Allah Hafiz. Assalamu alaikum and welcome to the Medicinal Chemistry notes. Today we are going to discuss about the synthesis of phenyl salicylate, commonly known as Solal. The basic structure is comprised of the derivative of the salicylic acid. Here is the structural representation of Solal, also known as phenyl salicylate. Now let's discuss about the steps involved in the synthesis of phenyl salicylate. As usual, the starting compound for the synthesis of phenyl salicylate is the salicylic acid. Undergoes certain condition, the heating arrangement provided, and it's converted into the phenol and carbon dioxide. Again, the salicylic acid molecule went under reaction with this phenol in certain conditions, leaving behind one water molecule. So there is a condensation reaction and it forms phenyl salicylate along with the molecule of the water. This step is known as the heating salicylic acid alone. Another mechanism or the steps for the synthesis of phenyl salicylate is by heating salicylic acid and phenol. The first one is salicylic acid alone. Now we are going to heat salicylic acid with phenol. So once again, the salicylic acid heating with the phenol in the presence of POCl3, it forms cellol. I hope this makes sense. Thank you. Allah Hafiz. Assalamu alaikum and welcome to the medicinal chemistry lectures. I am Dr. Akil and today we are going to discuss about the short synthesis of the sodium salicylate, an analog of the salicylic acid derivative, a class of NSAID and salicylic acid derivative compound. So the sodium salicylate composed of the benzene ring and the carboxylic acid is replaced with the sodium salt of the salicylic acid. So here's a synthesis, say two molecules of the salicylic acid and the sodium bicarbonate and sodium carbonate. It will lead to form COONA and OH. So this is the structural representation of the sodium salicylate. I hope you people like it. Thank you. Allah Hafiz. Assalamu alaikum. Hello and welcome to the Medicinal Chemistry. I am Dr. Akil. Today we are going to discuss the synthesis of acetanilate, the derivative of para-amino phenol, a group of NSAID, the class of commonly known as paracetamol. So let's discuss about acetanilate. Here is the structure. Now we are going to discuss about the synthesis from aniline and acetyl chloride. So this is the structure of aniline, benzene with NH2, and along with this aniline we are having CH3 C double bond O Cl. This is known as acetyl chloride. Okay, so we will be using some catalyst like salicylic acid in the presence of the pyridine as well. It will form NH C double bond O CH3 along with the side products that are HCl and CH3 COOH. So this compound, this new compound known as acetanilate. Okay, the second pathway for the synthesis of acetanilate is from aniline and acetic anhydride. Okay, so this is again I am drawing the structure of aniline. Along with the aniline, we are going to react this aniline with acetic anhydride. This is the general structure of acetic anhydride, and we are again using the same glacial acetic acid. Okay, and the compound that will be formed is known as acetanilate along with the two molecules of CH3 COOH. Another pathway for the synthesis of acetanilate is from aniline and acetic acid. So again we are going to write about the structure of aniline. Along with this aniline, we are going to react this aniline with acetic acid, and in this case the ZnCl2 will be used as the catalyst at 120 to 125 degrees centigrade, and the compound that will be formed is known as acetanilate. Okay, so I hope it makes sense. Please subscribe. Thank you. Allah Hafiz. Assalamu alaikum. Hello and welcome to Medicinal Chemistry. It's Dr. Akil Naseem. Today we are going to discuss the synthesis of phenacetin, another class of para-amino phenol derivative. So here is a structural representation of the phenacetin, that is NHC double bond OCH3 and OC2H5 phenacetin. The chemical name of phenacetin is 1-acetamide 4-ethoxybenzene. It's not acetanolate, it's acetamide. Okay. So let's discuss the synthesis step by step. What are the normal steps? The pathway from which the phenacetin can be synthesized is from phenol. Here is the structural representation of the phenol. This phenol undergoes a nitration in the presence of the HNO3 or H2SO4, and the resultant compound will be para-nitrophenol. Okay. So this para-nitrophenol undergoes further reduction in the presence of the FeHCl, and it will form para-amino phenol. Okay, so this is the basic structure, and this para-amino phenol undergoes acetylation in the presence of CH3 double bond OCl, that is acetyl chloride, and it will form the parent compound or the potent compound known as acetaminophen. This is the structure of acetaminophen. Okay, now this acetaminophen along with ethyl chloride under a certain pressure, it will form phenacetin. This is NH double bond OCH3, and along with this OC2H5. Okay, now this H and this Cl leave behind hydrochloric acid. So this is all about the synthesis of phenacetin. Please subscribe. Thank you. Assalamu alaikum. Welcome to Medicinal Chemistry lectures channel. Today we are going to discuss about the synthesis of diclofenac. A diclofenac, a class of the NSAIDs. Its chemical name is, here you can see, 2,2,6 dichlorophenyl amino phenyl acetate. The structural representation of diclofenac is just like this. We are having benzene ring CH2COOH. One carbon is bonded with NH, another benzene, and 2 chlorine. Let's discuss about the synthesis step by step. The first step is the N-phenyl 2,6-dichloroaniline undergoes Wolff-Fishner reduction, and resultantly it will form the intermediate compound. This intermediate, upon further hydrolysis and sodium hydroxide, yields diclofenac. Assalamu alaikum, medicinal chemistry lecture notes. Today we are going to discuss about the synthesis of mefenamic acid. Another drug belongs to the NSAIDs, non-steroidal anti-inflammatory drugs. Here is the basic structure of the mefenamic acid. The chemical name is N,2,3-xylyl anthranilic acid. The starting compound for the synthesis of mefenamic acid is orthochlorobenzoic acid. Undergoes reaction with 2,3-dimethyl-aniline. When these two compounds brings under condensation, they form an intermediate mefenamic salt or potassium salt of mefenamic acid. This, upon further treatment with hydrochloric acid, yields mefenamic acid by removing potassium chloride. Thank you. Assalamu alaikum. Welcome to Medicinal Chemistry lectures. Today we are going to discuss about the synthesis and their steps involved in the manufacturing of naproxen in medicinal chemistry. Here is the basic structure of naproxen. It has two enantiomers, that is plus and minus. Okay, now let's discuss about the synthesis. The first step in the synthesis of naproxen is the 6-methoxy naphthalene along with the acetic anhydride. undergoes acetylation and it will form a condensed ring, an intermediate compound that is known as 2-acetyl 6-methoxy naphthalene. Then this intermediate undergoes further esterification and alkylation and hydrolysis to yield the final product of naproxen. Thank you. Assalamu alaikum. Welcome to Medicinal Chemistry. Today we are going to discuss and learn the synthesis of indomethacin. A drug belongs to NSAIDs, non-narcotic analgesic. So the starting compound for the synthesis of indomethacin is 2-methyl 5-methoxy indole acetic acid. This undergoes reaction with, that is a tertiary butanol, along with another compound that is known as para-chlorobenzyl chloride. These three undergoes a reaction and forms a condensed ring. The first one is the indole acetic acid, the second one is the tertiary butanol, and the third one is para-chlorobenzyl chloride. Now this undergoes pyrolysis and it will eventually form the second compound known as indomethacin. Thank you. Assalamu alaikum. Welcome to Medicinal Chemistry. Today we are going to discuss and learn about the synthesis of piroxicam. Another drug belongs to non-steroidal anti-inflammatory drugs or analgesic. Here is the structural representation of piroxicam. It is a complex structure, so you people have to understand it. Now let's discuss about the steps involved in the synthesis of piroxicam. I will try to make it easier for you people, so it would help you go through your exams. So here is the first compound that will undergo reaction. The name is written over here, and along with the methyl iodide, the presence of sodium hydroxide, it will yield the second derivative of methyl 4-hydroxy 3,4-dihydrobenzothiazine derivative. Okay, then this undergoes further reaction with 2-aminopyridine, and the heat is provided, so it will eventually yield the piroxicam. Thank you. Keep subscribing me. Allah Hafiz. Assalamu alaikum. Welcome to Medicinal Chemistry. Today we are going to discuss and learn about the synthesis of ibuprofen. Another drug belongs to the category of NSAIDs, non-steroidal anti-inflammatory drugs. Here is the basic structure of ibuprofen. It's an easy one, but hopefully you people remember it. Now let's discuss about the synthesis steps involved in the synthesis of ibuprofen. The initial compound that undergoes the reaction is isobutylbenzene with acetic anhydride. These two undergoes acetylation and results in formation of a derivative known as para-isobutyl acetophenone. This acetophenone, upon further treatment with HCN, will yield this compound. Here is a structural representation of the compound that is known as cyanohydrin. This cyanohydrin, upon hydrolysis, eventually yield ibuprofen. Thank you. Allah Hafiz.